In 2006, 13.4% of all live births in the United States were to mothers under 20 years of age. A sociologist claims that births to mothers under 20 years of age is decreasing. The sociologist conducts a simple random sample of 41 births and finds that 5 of them were born to mothers under 20 years of age. Test the sociologist's claim at the alpha equals 0.05 level. So first, you have to ask yourself, is this a mean problem? They're asking us to do a hypothesis test about a population mean, or they're asking us about a population proportion. So because they give me a percentage right away, that's a proportion they're giving me. And they're saying in 2006, 13.4% of all live births were to mothers under 20 years of age. So they're giving me a proportion right up front. And then they later give me the information to find that proportion, the second proportion. So they say the sociologist conducts a simple random sample and finds 41 births, and 5 of them were under 20 years of age. So yeah, this definitely, they don't even say the word average here at all. So, or mean. So like, this is definitely a proportion problem. So we have to make sure that these preliminary questions are met before we're able to do a hypothesis test for this problem. So is it safe to assume that the sample size here, which here is 41 births, is less than 5% of all mothers under 20 years of age in the United States? So let's just, if we take 41 and divide by if we make this into an equation, then it's n equals 5% of all mothers. Then you divide by 5% on both sides of the equation. And you get the number, the smallest possible value of n that would work. So, this equation says n is less than or equal to 5% of all mothers, so 0.05 of n, the large n, which is all mothers. So if I divide that equation both sides by 0.05, and the n here is 41, that's the number in our sample, then we can get an idea of what n can be. So 41 divided by 0.05, and I get 820. So if you think that in the United States, if there's more than 820, mothers under age of 20 in the United States, which there definitely is, then it's safe to assume that the sample size is less than 5% of the population. So I would say yes, it's safe to assume that, because there's much more, there's a lot more mothers under age 20 in the United States than 820. So this was 820. So that means that our n to make this work and our large population has to be greater than 820. So anyways, that's good. And then it says verify that n times p times 1 minus p is greater than or equal to 10. So what is n times p times 1 minus p? Well, the n here is the sample size, which is the 41. The p here is the proportion, what we believe the population proportion to be, which is the 13.41.4. So that's turned to decimal point 0.0143, and then 1 minus 0.1434. So I minus that. Okay, so I just enter that all into my calculator. Let me see if I can get. So you can see the calculator on the screen here. So I just input the 41 times 0.134 times 1 minus 0.134. And then I go enter, and that is, unfortunately, that value is not greater than or equal to 10, right? So we calculated what this is. That is 4.75, and it is not greater than or equal to 10. So this is not true. So we can't use, in this case, we can't use the normal distribution. We can't use typical tests that we would normally use to find the p-value here. So what we can do is we can use this binomial distribution instead. So so there's the 3.4, or the rounded to just one decimal place, it was 4.8. And then this can be binomial distribution. So let's continue on this problem. We can still do this problem, we just have to use different, we can't use that regular t-test, the one prop z test that we would use for a typical problem like this. Without being given the population is normally distributed and that n to c to the minus t is less than 10, we cannot assume the normal distribution, and we are required to use binomial distribution. So now we just continue on. They ask, what are the null alternative hypotheses? So I would say the null hypothesis, sometimes it's easier to identify the alternative hypothesis because a sociologist claims that births to mothers under age 20 are decreasing, or is decreasing, that age is decreasing. So actually, the age is not decreasing, the number of births is decreasing. It's decreasing from what? It's decreasing from this 13%, right? So I would say the null hypothesis is that the mean, the population portion, the proportion of babies born or live births born to mothers under age 20 is equal to 13%, which I would write as a decimal. So 0.0134, and then the null hypothesis, or the alternative hypothesis is the proportion has decreased. So I would say the proportion is less than 0.0134. So to make a left tail test, okay, so that's how we get these answers right here. Okay, then they say, based on the hypotheses, calculate p-value using the binomial distribution. So we can grab this, and if we think about it and calculate it like a binomial probability, what is the probability? We would be asking ourselves, what is the probability of getting exactly 5? Or actually, because probability hypothesis testing is always, a value or smaller. So we want to know if this is 5, if what the probability of getting 5 or smaller bursts out of 45 and 41. And that's because we want to know the probability of the proportion is smaller than 13.4. So I would do this calculation, x less than or equal to 5, which you would need the binomial CDF because the binomial CDF will do the probability of it's exactly 5, less than 5, and less than 5. So let's look at what we need. So we go stats. Oh, and we go I believe it's calculate. No, I think it's distribution. Sorry. So bars. Second bars to get the distribution screen. And then binomial CDF. Oh, okay. It doesn't want to allow me to do that. So let's go to the class calculator because I think that one will work for me. That's fine. So stats, distribution, binomial CDF distribution, CDF, and it's looking for the N and P, the number of trials and the probability of success. So the number of trials was 41, because that's the number in your sample. And then the probability of success is just what we assume to be true in the null hypothesis is 13%. And then we want to know less than 5. So you could say between 0 and 5 would be fine. And we get this 0.523. And so that is our p-value for this first part, which is like really big for a p-value. So that is the p-value. So it's 0.5239. Let's see, where is it? 0.5239. Yep, that's the number we want there. And then the p-value is really big compared to the level of significance is 0.05. That's like 5 pennies, if you will. And this is like 52 cents. So the p-value, so we always ask ourselves, is the p-value less than alpha? And here it's not, right? So we would say we fail to reject the null hypothesis because we reject the null hypothesis only when the p-value is less than alpha. And here the p-value is not less than alpha. So we fail to reject the null hypothesis. And then the conclusion regarding the claim, we always say there is not sufficient evidence. There is not sufficient evidence to support the claim. And then we have to really think about what was the claim again. The claim was that, and if we scroll back up, we find the claim was that the sociologists they thought that the number of births to mothers under age 20 is decreasing. So there's not evidence to support that claim. So make a conclusion regarding the claim. I would say there is not enough evidence to support the claim. And there we go. And let's just double check it. There we go. That's our problem. All right, I hope that you found this helpful. Do note that whenever we do have to use this binomial experiment, be careful. I know we did two types of binomial probabilities. We did x is equal to 5. We did that kind of calculation, and that was a binomial PDF. We don't want to use that here in hypothesis whenever we use binomial distribution to calculate a probability. We always want to use the less than or equal to 1. Or it could be if we use the less than or equal to 1 because this was a left tail test. However, if this was a right tail test, we would have had to use the 1 minus rule to find the 5 or bigger. So, but that's for another day. All right, have a great day, and let me know if you have questions. Bye.